All right, so question number one on upper intermediate. So once again, our friend Daria from Russia has proposed a question. This is one of the most complicated questions on the intermediate level. This is almost an advanced question, almost. Yeah? So trying to understand what the problem is. So we got a list of people, yeah, and we want to find someone. Yeah, that's easy. So who is the person we are looking for? The person we are looking for is that one who managed to pick the higher amount of apples. Yeah? So the algorithm here is the players pick some fruits. They also smash other fruits, unfortunately, and all of that happen in a given amount of time. So we want to see who is the most productive player. Let's say who got the highest score, and the highest score will be determined by number of picked apples. For instance, Susie got 30 apples, but obviously we need to discount the number of smashed apples. So in that particular case, so how many apples Susie pick? So 30 minus 3 would be 27. But we also need to consider the time dimension because Susie got 27 fruits in 1 hour. So the performance is 27 fruits per hour, let's say. So what about Tariq? So Tariq got 28 apples. He smashed 4. So in total he got 24 in 1 hour. So if we compare Susie and Tariq, clearly Susie is more productive, yeah, because it's 27 versus 24. What about Poppy? So Poppy smashed more apples than she managed to collect, which is a bit exotic. But so the productivity of Poppy is negative because she's destroying things, right? Literally. So in this particular use case scenario, Susie is the most productive employee or player, whatever. I hope you get the idea of the algorithm. We need to do pick minus smash divided by the time, and that's the complicated bit because time is not a number. If that was a number, it could be easier to deal with, but it's not a number. It's a string. So we need to be able to extract the number in that string somehow. Let's see how we deal with the issue. First of all, let's set up the problem. So the function name is get competition winner. So let me write down the function name. Function get. Oh, what the hell is that? Get competition winner thing. So we got a list of players. And now let me think about the best way to deal with the problem. So essentially, we want to find the top player. So let me create a variable called top player equals whatever. I don't know yet. Eventually, if you pay attention to the details, guys, we don't care about the whole object. We just care about the name of the player. So if assuming top player is an object with all the details of that player, let me just do return top player dot name. So now it's all about building the algorithm. Yeah? We have to iterate. Over all the players in that list, and then we need to find the top one. There are different ways we can attack the problem. We could use a map. We could use short. I don't know, different techniques. I'm going to use reduce. I'm a big fan of reduce. It's very powerful. So let me try to use it. So I will use players.reduce. So then I will set the top player eventually on the accumulator, and then I will iterate through each player. So the idea is, look guys, return if get a score of a player is greater than get score of top player, then return player, else return top player. You see the idea? I'm gonna iterate through all the players, and then I will compare the score associated to each player. If a given player has a higher score than whoever was on top at that moment, then the new top player will be that one. If not, we will keep the top player as it was, right? So now obviously it's up to us to build the get score function. So let's create a new method at the bottom, get score, that receives the player. And then we need to deal with pick, smash, and time. We can even destructure it if you want. Pick, smash, and time. And now the idea is to do something like that. Return, so picked minus smash divided by time. What do you think, guys? Will this work? Yes or no? And why? Why not, Minji? That's correct. Minji is right. So time is something like 0.5 hours. So we don't care about the hours. I mean, we are assuming, guys, we're assuming that all the time is based in hours. We don't want to mess with minutes, days, and things like that, right? So let's assume that we're all the time playing with hours. So we just want to get the number, the numeric part associated to that string. So can anyone tell me how can I get the 0.5 out of this string? Parse what? That's interesting. Look, there are, guys, I'm gonna propose you 3 different ways of solving the problem. The first one will be, so let me create a variable, actual time equal, and then look, you can do time dot. So you can get the substring associated from the beginning to where? To time dot index of space, something like that. You get my point? So I want to get the substring from the beginning of the string until the position of the space. Something like that. I don't want to say this is exactly the precise way of solving the issue. I'm just presenting you the approach. So that will be the first approach. The second approach, let me create another variable, will be to run, look, time.split. Yeah, and then what else? Can anyone tell me how to complete this line? That's correct. That's correct. Square bracket 0. That's correct. Yeah? You see? So I get 2 tokens. First of all, the numerical part, and then the string. I don't care about the string, so I just keep the first one. It goes without saying we should transform all these things to a proper number, yeah? Because without that, we get a string. And then, based on what Minji suggested, actual time free. So she's suggesting to do parse int time. What do you think about that, guys? Will that work? Parse int? Any thoughts? That's correct. That's correct, Ian. Look, if you do that, if you do parse int Minji, it will work as far as you got integers, like 2 hours, fine. 1 hour, fine. 12 hours, fine. However, on the exercise, you got things like that. You got decimals. So you cannot use parse int. You can use parse float, which is pretty much the same thing, but parse float understands the decimals. Yeah. So parse float will do its best in order to find the number encapsulated in this string. So let's see if that works, guys. So let me create a variable called actual time. So now we can do picked minus smashed divided by actual time. So, can you spot any problems, guys? Can you see any reason why this algorithm won't work? Hello? Anyone there, guys? Are you still sleeping? Is anyone interested in this session, by the way? Okay, so let's just evaluate it to see if it works or not. Oh yeah, so that works. Yeah. And now, so yeah, that's pretty much the algorithm. And now questions, guys. That was the most complicated question probably on the entire JavaScript intermediate training. So any questions about it? That's a really good question. That's a really good question, Adam. Yes, yes. So what you could do, something completely different, is I will do something like that. Players.forEach, or sorry, let me. It will be much more complicated, that's for sure. But the plan will be return players.map. So for each player, what they will do is player.score equals, and then return player. So I will be essentially adding a new property called score. Yeah. Once I got that, then I can use sort, as you said, sort player A, player B. So then, guys, do you remember how to sort an array of objects? So if I want to sort the array descendantly, how will I do it? That's interesting. Exactly. Remember the rule, guys. Remember the rules. So when sort returns a negative number, so that means sort the array descendantly. When sort returns a positive number, sort the array ascendantly. Let's see if I if I say that in the correct way. So imagine we got an array of 3 and 4, two numbers. Yeah. So if we do a minus b, will be 3 minus 4. So 3 minus 4 returns a negative number. So that will sort. Oh, wait a minute. Maybe I did that on the other way around. Sorry, guys. I always struggle to say that. What I always do is, if it's a minus b, if you do a minus b, that will sort the array ascendantly. If you do b minus a, that will sort it descendantly. Yeah, that's the result. And now we probably need to rephrase that a bit. So return when sort returns a negative, probably that should be on the. No, that's on the other way around. That's my fault, guys. I mentioned that on the other way around. So when sort returns a negative, then sort the array descendantly. That's that example. If you, to simplify things a bit, if you have an array of 2 elements, 3 and 4, yeah, when you do 3 minus 4, obviously that returns minus 1, which is a negative number. So when it's a negative number, then it will sort the array ascendantly. However, if you do on the other way around, 4 minus 3, yeah, that returns a positive number, obviously, because 4 minus 3 is 1. So that will sort the array descendantly. To me, these type of problems are much easier to present with an example than with explaining the theory. Yeah. So once again, you do A and B. So if you do A minus B, that will sort the array ascendantly. Yeah, remember A ascendantly. A ascendantly. If you do B minus A, that will be on the other way around. That will sort the array descendantly. Descendantly means the first element of the array will be the highest one, and the last element of the array will be the smallest one, obviously. So based on that, Adam, can you tell me how to complete the exercise? That's correct. That's brilliant. That's correct. You can not sure about the indentation in this occasion, but it should be something like that. Yeah. So that should be the equivalent version. Let's test it. Let's see if it works. Yes, it works. Yeah. So the difference is we had to loop multiple times. First of all, we are transforming the original array by adding a new property called the score. And then once you got that property, it's very easy to sort it. Yeah. Because we can actually do that. You may be thinking, can we just skip the map step? So can we actually do something like that? So can we call sorry, not actual time, get score of player B minus get score of player A? Yes, that's the same thing. That's the same thing. If we evaluate it, oh, Yurton Sushi. Oh, what the hell is that? Sorry, I did something. Probably it's a typo somewhere. Let's try to find the problem. Get the score, player A, get the score. I broke the code somewhere. Let me go back to the step to see if I can see where the problem is. Type error. The structure picked of undefined. Ah, that's a bit weird. What the hell is that? So can the structure property be of undefined? So at some point I'm passing an undefined. Wait. Sorry guys, that's because of the copy and paste. Let me show you. So look at the problem. It says cannot the structure property picked of undefined as it is, and then you pay attention. Obviously, I want to get the score of the object. You see, I was still, because of the previous example, passing the property score of player that doesn't exist. Yeah, so that was a silly mistake from my side. So let me go back to mobile mode and let me run it and see if it works. See, that still works. Which approach do you prefer and why? This one, where you essentially get the score of every player all the time and you compare by pairs, or the other one where you first of all got the scores and then finally you once you got the scores you just sort the array. Which coding style do you prefer and why? Okay, yeah, fair enough. So the reduce is the first one I presented, but let's ignore the reduce approach for now. Yeah. So in between of this style and the one I presented you before, which was something like that. Yeah. Yeah, and that one. So do you prefer to map to get the score and then sort, or do you prefer to skip the map step and then sort directly by calling get the score all the time? No use of map. Okay, why? Again, I'm not telling you you are right or wrong. I'm just trying to get some answers from you guys. So why do you prefer the second style, Adam? That's a good look. Even though I may not necessarily agree with the answer, I at least I agree with the way you argue it. Yeah, of course, you write less code, it becomes more readable. So from a human point of view, I agree with you. From a machine perspective, from a hardware point of view, let's say, which approach is more efficient? With map or without map? I can copy it again underneath so we can probably see both styles side by side. So you see, we got the same question written twice. So, all right, I agree with Adam. From a readability point of view, the one at the bottom is, easier to read, right? Fantastic. From a hardware perspective, which one is more efficient? Why the top one, Adam? Yeah, but okay, fair enough. But that's not the reason. It's not about how performant map is, guys. Let's talk about algorithms. How many times are we calling the get score function on the example on top? How many times? Why 3 times, Ian? Correct. So we call the get score function as many times as elements the array has. So if we got 3 times, if we got um, 3 players, we call it 3 times. Imagine that get score function is a very heavy one because there is a complex algorithm in here. So from a mathematical point of view, it's a complex function. So we need to try to limit as far as possible the number of times we invoke it. On the second exercise, the one at the bottom, how many times are we calling the get score function? 6 times. Why 6 times, Ian? That's interesting. Look, let's actually get the actual number. So we got 3 players, A, B, and C. So we are comparing A with B, and then we're comparing A with C, and then we are comparing B with C. Yeah? So we need to compare them. We need to compare 3 elements, or we need to run the short algorithm 3 times. Yeah? And now, obviously, on each iteration, we want the score of the first one and we got the score of the second one. We want the score of the first one and we got the score of the second one. Yeah. So Ian is actually right because we are calling get score twice on each iteration. So from a performance point of view, the second solution is less performant. And guys, I'll tell you something. If we got 3 elements, yeah, it runs 3 times. But how do you imagine that, for instance, if we got 4 players, on the first use case scenario, we'll call the method 4 times. But on the second one, look, we compare A and B, A and C, and then we compare A and D, and then we compare B and C, and then we compare B and D, and then we compare C and D. You get my point? 1, 2, 3, 4, 5, 6. So there are definitely lots of possible combinations in here. And in this particular case, the cost is not double. It's not 3 versus 6. It's 4 versus 12. So I hope you get the point. The larger the array is, the less convenient this strategy is. In other words, dealing with sort is controversial. You need to be careful of the operations you run when playing with sort, yeah? Because sort can be very slow. You see, there are many things that you may want to compare when using sort. Once again, if you got 3 elements, does it make any big difference? Probably not. Probably not. So if I had 3 elements, I will probably use the one at the bottom, because even though it's technically speaking less performant, it's more readable. So thinking on humans, as Adam said, I will probably use this one. But if you need to for instance, migrate a database by changing something that will require quite a lot of computing efforts, then you should really be careful and you should really look after this type of operations. Any questions, guys? Okay, cool. Let me share that on Slack as well, so you can play with it a bit afterwards. Yep. Yep. I personally prefer the first one. That's a personal opinion, but this is based on my coding style. Yeah, because just by using reduce, it's one method, I can solve all the problems. You may be thinking, yeah, but you are calling get a score twice. That's right. This is maybe not as performant as saving everything into map and then using sort. However, on the other way around, we just iterate the list of players from the beginning to the end. So yeah, I don't necessarily think that's such a bad algorithm. Once again, this is based on personal feelings, guys. I'm not very opinionated here. Anything else, guys? Any questions? Let me ask you something then, because we've been talking about parse in, parse float. Can you tell me, guys, 3 different ways of transforming 5 into 5? String representing a number into a pure number. So the string, all right, wait a minute. So the string is called string number equals 5. So how do we transform it to a number? String number, correct? Okay, tell me a different way of solving the problem. Anyone? Plus? Yeah, okay, plus a string number. Okay, and give me another one. Parsing. All right. Parsing. Fantastic. Parsing a string number. Let me focus on these two: number versus parse int. Which one? That's a classic job interview question, guys. Which one do you prefer? Number. Why? Adam? All right, semantics. Okay, that's a reason. Anyone else, guys, has any reason to use either number or parse int? Yeah. Okay, yeah. No, fantastic. I'm not against using the plus. The plus is essentially the same as using number. So I don't care. Yeah. So look, Ian is introducing a new rule here. Ian said, hey, they are not fully equivalent. Because if instead of 5, I got 5 hours, then parseInt will work better. ParseInt will return 5. Number, what will number return, guys, if we pass 5 hours? That's correct, Ian, not a number. So if we don't have a number as such, represented by a string, if we got something more complicated, like a number followed by a piece of text, then yes, parsing will do the trick. Number won't work. But if we just have a number, both will work, right? In this particular case, number and parsing will be equivalent. So, do you have any strong reason, apart from readability, as Adam suggested, to use one over the other? Now, let's ignore that case. No, yeah, all right. So if we got more complex data structures, then parsing is the only way. But if we just have a number, we can use both. Both will, technically speaking, return the same output. However, guys, there is, yeah, go for it. No, you are not using decimals this time. No. Yes. Why number then? Right. Okay. I'm not arguing that. I'm not arguing whether readability is better or worse. However, that's not the reason. That's not the reason why number is the preferred option. The preferred option, let me show you, is performance, guys. Number versus parseInt performance. So hopefully benchmarking JavaScript string to number. So let me try to find parsing number. No, there were some very good benchmarks. I need what's the difference between performance comparison? There was a very good website somewhere. Run the benchmark. Yeah, maybe parsing this one. I don't know. I didn't prepare that much, but let's see if I can get some meaningful results. Render, run test. Yeah, I want to. That's a bit strange. Yeah. Well, even though I cannot show you what I wanted, let's try to, rather than giving you a number or a number telling you how much performance number is against parsing. Think about something, guys. When you use parsing is way more complex. It's way more powerful in reality, because if you got £5, parsing will be smart enough to detect there is a number, while number method will just give up, returning not a number, as Ian suggested before. Yeah? So parsing is way more powerful. However, that power doesn't come for free, because it's more powerful. Eventually, it makes the processing slower. So if you know that you got numbers represented by strings, then number is the way to go. Yeah? That's a classic journey in a job interview. Yeah, they may present you a problem when you got something like that, and they want to see if you use one or the other. So number, historically speaking, has been preferred over parsing. And that's it. So, any questions? Thank you, guys. So, because we are running quickly out of time, as promised, I would like to solve question number 3 on the advanced level. That's the only one that Dan didn't manage to solve. Look, You remember at the beginning of this session, I told you there are 3 stages when talking about this particular problem. The first one is positive, like, oh, that's a piece of cake, right? At least from a human point of view, it is very easy to identify, the problem at least. Yeah? So get the most repeated character. You get a string or a sentence, whatever, yeah, piece of text, and you want to identify where is the most repeated character. So if I got Codery, the most repeated character is I. Why I? Because I is listed twice. All the other characters are listed once. Yeah? That's the idea. If I got the word bootcamp, the most repeated character is O, because it's twice. Yeah? Once again, that's pretty much all about it. But now, let's solve the problem. That's a bit more tricky. It's not that simple. It's not that simple. I'm going to present you my preferred data structure. It may take you a while to find your data structure. Yeah, but once you find it, once you find an appropriate data structure, the problem becomes much simpler. So I would like to do divide and conquer here. Divide and conquer means I want to split the problem into 2 parts. First, I want to get a character map. For instance, if I got the word Codery, I want to have something like that. K is 1. O is 1. D is listed once as well. I is listed twice. And finally, R is listed 1. Something like that. Yeah, you see? I'm building an object where I have all my keys of my string, K-O-D-I-R, and then a number representing how popular, how hot each character within that string is. Once I got that, the second step is loop over the characters map and return the most popular one. 2 steps. Yeah? That's what we call divide and conquer. We are dividing a complex exercise into 2 parts. So then I would like to add some sort of breakpoint in the middle after finishing the first part. If the first part, or once the first part is correct, then I'll jump over the second step. So the first part will be something like that. I'm creating a variable, characters map, and then I will use string.split. Why split? Because I want to access each character individually. Instead of Codery, I want to get K, O, D, etc. Yeah? Split the string, and then I'll use reduce. So with reduce, I will essentially build my map of characters. Because I'm creating an object, the default value of my accumulator will be an empty object. So now my plan is, if the first character will be K, by default, we don't have any value. We don't have any key value in this object. Sorry, guys. We don't have any data. Yeah? Because we don't have any data, we need to build it. So if I don't have any key value associated to the character K, then I will initialize it. I will init it. Characters map of character equals 0. Then I will increase the counter associated to that character. So characters map of character plus plus. And finally, before I forget, I will return the list of characters. You see, that's my first step. I want to build a list of characters. Let me do a console.log. Or let me actually return. That's not going to work, of course. That's not going to work. So I'm sacrificing the accuracy a bit. but I want to see if at least the first half of the exercise is correct. Let's evaluate it. Look. You see? That's exactly what I wanted. K once, O once, D once, I twice, R once. Yeah, that's exactly what I wanted. However, guys, will it be, am I ignoring the spaces as the exercise suggests or not? Not yet. Not yet. Not yet. Because I don't want, guys, if you pay attention to the last example, JavaScript is very nice. The most repeated character is the space. It's listed 3 times. And you can actually see that's a bit weird. You see, guys? You see where my cursor is? I got an empty space listed 3 times. That's a bit weird, right? So we don't care about the empty spaces. So what we can do, we need to remove the spaces, right? So, I mean, there are multiple ways of dealing with the problem. So, for instance, we can just have another if here. If character is not a space, then do whatever you want to do, right? Of course, we could split and remove the spaces in a different way. I'm not against that. Yeah, there are different techniques, of course. You see? So if I run it again, hopefully, you see, now this time I'm not tracking the empty space because we don't care about it. So that's the first step. Do you have any questions about building that map of characters? Thank you, Ian. So before going any further, I'm going to abstract that. I'm going to move that into a different function. Get characters map, or I pass the string, and it will return all these things, right? So return, actually, yeah. So we return get characters map, yeah. So characters map equal get characters map of a string. And now the second step is, hey, I got my list of my map of characters. So how do I get the most popular one? The most popular one in that particular use case scenario will be I. So let me do something. Let me get all the keys, K, O, D, I, R, and then I will check the value associated to these keys. How in JavaScript, guys, can you get the list of keys of an object? Can anyone tell me? Fantastic. Fantastic. That's exactly it. Object keys of characters map. And then, once again, I'm going to use reduce. That's pretty much the same thing I did on the intermediate exercise. With reduce, I will check all the keys, and if the value associated to a key is higher than whatever the previous value was, I will keep it. So, reduce, most repeated, and then I got the key. So each key is a character. So for readability purposes, let me call it character. So now what I'm doing here is return most repeated character. So we're talking about individual characters. So to get the value associated to that character, the only thing we need to do is characters map of most repeated of character if you want. So I want to check if the value associated to its character is greater than whatever the value associated to the most popular one was. If a character is more popular than whoever was the most popular, then return character. Else, continue keeping the most repeated as it was. You see, and eventually that will return the most repeated character. What do you think, guys? Will this work? Yep. We can unroll the exercise then, if that any helps. So we can do the iteration journey. So on iteration number 1, um, can so in this particular case, yeah, you got Codry. So Dan, can you tell me what is the most repeated? Not Dan, sorry. What's the, the most repeated character on the first iteration? Dan, it's a K. That's correct. That's correct. Why? Why? Can you explain why it's K? That that's correct, because we don't have any default value. You're absolutely right, Dan, because we don't have any default value on the reduce. So then reduce will take the first one, which is the K. That's correct. So then, for instance, Adam, can you tell me what's the value associated to characters map of? Sorry, no. Let me go back in time. So what was the first character, Dan? The first character. Do you agree on that? Is the first? So is the most repeated? Are these the same then? So Ian disagree on that. Why, Ian? Or Adam? Exactly, exactly. Adam is right, because we don't have any default value, any initial value, as Adam said. The first one will be the first on the list, the K. But then the first character has to be the second element on the list. Yeah, so that's the O. Sorry, guys. That's the O. So then, what is most repeated associated to the character? So, for instance, Minji. Sorry, that's not correct. Something went wrong. It's characters map of character. I'm here, line number 6. So Minji, what do we got here? It's 1. That's correct, because characters map is here. The O is 1. So yeah, characters of map returns 1. And now, Ian, what is characters map of most repeated? It's 1, right? It's the same thing. Most repeated is the K, so it's 1. And now the question for Dan. What do we return on the first iteration? We return K. That's correct, because characters. So we're comparing 1 versus 1, which is falsy, because 1 is not greater than 1. So we keep the first character as it was. Yeah? And then let me do the second iteration. On the second iteration, most repeated character is still K. Yeah? That's what we return on the previous one. Next character will be D. Yeah? So what's the value associated to D? It's still 1. Is 1 greater than 1? Not yet. Not yet. So we keep the key. And now, let's talk about the third iteration. So Adam, what's the most repeated character so far? That's correct. So now, Ian, what's the next character? It's I. That's correct. So what's the value associated to the character, Minji? It's 2. That's correct. The most repeated was 1. Still K was the king of the most repeated character. But now look what happened, guys. 2 is greater than 1. So now the new king of the popularity, the most popular character now will be the current one, which is I. Yeah? And on the last iteration, nothing will change, because now we are comparing the last one. R will be 1. 1 is clearly not greater than 2. So we will continue keeping the I. So I will be the most repeated character. So that's pretty much the idea. To me, you see that's quite complex, but once you break it down into 2 steps, it becomes much easier. Now my question is, not my question, my comment, my final comment is, this won't work, unfortunately. One of the use cases scenarios won't work. Let me test it, and then hopefully you can tell me which one. Actually, 2 of them. Oh, wait a minute. Why the last one didn't work? Let me get rid of the comments. You know, sometimes the comments are a bit temperamental. Sometimes comments make the code to break, which shouldn't be the case, of course. So let me test it again. Am I doing something stupid, guys? The capital. What do you mean the capital, Minji? Yeah, no, I don't think it's a capital. I think there is a typo somewhere, but because once again I'm in mobile mode, I cannot see the typo. So let me get the elegance console. Here you go. Reduce. You see that's the problem I was mentioning before. So the problem here, guys, is on the third use case scenario. Let me show you. On the third use case scenario, our map is an empty object because we got nothing. And then look at the error. Type error. Reduce of empty array with no initial value. Yeah? So it doesn't work. It doesn't work in the use case scenario where characters map equals empty object. Because when you do object.keys of an empty object, that will return an empty array. And when you do empty array.reduce and you don't have any default value, what's the default value then? There is no default value. Yeah, there is no default value. So you know that doesn't make sense for JavaScript. Yeah. So thinking on that particular use case, look at what happened. So if we got nothing, then return just nothing, just an empty string. So I believe we can do that. We can say, hey, by default, character is just an empty string because JavaScript will probably return it if there is nothing on the list. But now I'm breaking everything else. You see, I'm just turning around how to solve the problem. So now I'm solving the third use case scenario, but I'm breaking everything else. It's returning an empty string all the time. And why is it returning an empty string all the time? I believe that's because now the first most repeated character, guys, is an empty string. So when we try to do characters map of an empty string, that will return what? Probably undefined. So then you see we got a weird comparison here where we are comparing a number versus undefined. That smells, guys. So to change the approach a bit, I will simplify the problem. Look, I will do if I got a string, then do all these things, right? See, if I got some data, then iterate, then check data. Else, if I don't have any data, then just return an empty string. Not sure, guys. I'm not sure if that's the most elegant way of solving the problem, but I find this quite pragmatic. Yeah? I'm sacrificing the corner case where it's not having any data, but at least I keep the rest of my algorithm clean and tidy. So you can see that now, after introducing this basic if-else statement, everything works as expected. Last thing I will do here, because that algorithm on top is quite complex, I created a function called getCharactersMap. So then I'm going to create another function called get most popular character. I'm just now refactoring my code. I'm just moving things around. Yeah, as you can see. So now I will essentially delegate the responsibility of getting the most popular character into a new function that obviously receives the list of characters and then return them. You see? So now, I hope you agree with me, the main method, get most repeated character, is simpler, easier to read. If I got a string, then first of all, get the map of characters, and then once you get the map of characters, then, okay, return the most popular one. Else, hey, if I don't have any string, then just return an empty string, because there is nothing to deal with. Just an empty string, right? And then that works, as you probably have seen. So now, questions. Sorry, guys, I got my headset disconnected right now. So can you please repeat the question?
You're on mute.
Oh, am I? Oh, what the hell? Sorry, can you hear me? Can you hear me now, guys?
Yeah.
I got my headset disconnected a second ago. Don't ask me why. No, I was just checking if there was any questions about this algorithm, which I just shared on Slack, by the way.
Oh, I just want you to have a look over my solution, if possible.
Yeah, of course. Well, before that, any question, guys, regarding this approach, this algorithm?
No, good. Interested to see what the guys tried.
Okay, let's have a look. Let's have a look. So Ian, you see, so Ian did something completely different, which is more compact. So what Ian did is he's creating an array with all the individual strings. You see, that's the way he's getting an array of characters. And then he's having an object where I believe he will save the most popular character and what is the number of instances associated to that character. And then what he does is he iterates over all the characters in the list, setting the counter as 0. And then he, I believe, counts how many times each character on the list is displayed. Yeah? Eventually, he says, hey, if the number of instances of that character is greater than whatever the previous one was, then I update it. Which is very smart, of course. It's very smart. It's even simpler than what I did. Yeah. So yeah, that's brilliant. Yeah.
I think the only thing I just realized when you made your example, it's that I forgot to handle the spaces.
The spaces.
Yeah, I think I need another condition before for each.
You need
because just now they take I 3 and space is 3, but 3 is not greater than 3, so it takes the first character which is bigger.
But why is that? I don't get why is it working if you are ignoring the space. For instance, on the last use case scenario, right? The most repeated character. I see what you mean.
I is the first one.
Is the first one. Yeah. I see what you mean. Yeah. So, guys, can you see the problem? That's a good point. Yeah, that's a really good point, actually. So, even though it works for Ian, on the last use case scenario, it works not by accident, but by luck, because you see the I is the most popular character. There is a draw between I and the space. Yeah, both characters are listed 3 times. Space 1, 2, 3. I JavaScript is nice 3 times as well. But because the I is listed first, eventually it will be highlighted as the most popular one, because it's listed first. So then at some point the space will be 3 versus 3. 3 is not greater than 3, so the space won't override the I, right? That's the only thing. So you're right. To be fully precise, Ian, you should definitely ignore the spaces in a more explicit way somehow. Maybe an if-else somewhere inside of the for loop, something like that. Cool.
I think before for each, I think it's working.
Yeah. Yeah, absolutely. I'm going to share your solution on Slack as well. Yeah, because I really like it. Nice one, Ian. Anything else, guys? Any questions?
Yeah.
It definitely looked easier than it is.
Yeah.
Ricardo.
Yeah. I agree. I agree on that. Cool. Anything else, guys?
No questions.
Cool.
Good.
Thank you very much, guys. Thank you for joining. Thank you for the challenge. Good effort.
Thank you.
See you
Okay,
later.
thank you.
Happy coding. Bye bye.
Bye.